I would like to invite Angus to the floor now. Angus, over to you. And of course, enjoy the session.
Thank you so much, Violetta, and thanks
You're welcome.
everybody for joining us today and giving us a little bit of your time to allow us to tell you about Oracle's hybrid cloud container management platform. So my name is Angus Myles. I'm from a group in Oracle called the Oracle Solution Center. I'm joined by two of my colleagues, Mundy and Arif, and as you can probably tell by our backgrounds in Zoom, we all live in the same flat apparently. And we're also lucky enough to have Joshi with us today, who's a Director of Product Management for Enterprise Cloud Native Java. Sid and Mark are going to take some time to answer your questions in the Q&A, so they're going to use their expertise to furnish you with some answers. So please use the Q&A. We do love questions, and we'll hopefully have some time at the end for them. And Arif and myself are going to do a demo. I've got the boring part, I've got the slides, and Arif has got the exciting demo where he's going to show you on-premise Kubernetes interacting with our managed Kubernetes offering in Oracle's public cloud as well. So I hope that's okay. We're going to press on. And this is our agenda. We'll talk a little bit about some of the challenges. We've got a poll for you. I will introduce our solution in that space, which is Verrazano, what Verrazano has in it, what it offers to you. And then we've got a demo from Arif, who'll show deploying our first application to the Verrazano platform. And then we'll talk about how we extend our Verrazano platform, how we add additional clusters, whether they're on-premise or they're in the public cloud. And we'll finish with another demo from Arif that shows us that working and extending the setup we have in our lab currently. So like you, we spent plenty of time working with container native solutions, deploying those for customers in our pre-sales work that we do with lots of customers around EMEA. And we know the excitement of getting our first application up and running. It's a great feeling. We get that deployed to our Kubernetes cluster. And then we realize the hard work is only just beginning. We realize we need to know what's happening inside our application. What metrics, how is it behaving? What metrics is it emitting? What's happening in those logs? That might tell us if there's some errors or some bugs with the application we've deployed. How do we manage customers coming in and accessing clients coming in and accessing that application? And you pretty soon realize that vanilla Kubernetes is not enough. You end up becoming very, very familiar with the command line, and you really need some extra help. And then we add to the fact that you may need to manage multiple Kubernetes clusters. You maybe need to have one for dev, test, pre-prod and prod. Maybe you're running Kubernetes clusters for individual applications, and the workload becomes pretty severe. And you realize that you need additional components, you need additional help with logging, observability and management. How are you going to manage and upgrade multiple Kubernetes clusters that you have running perhaps on premise or in the cloud? And it's perhaps not surprising really, because even the creators of Kubernetes describe it as a platform for platforms. So what you really need is a platform on top of Kubernetes to ease the tasks and the workload of producing exciting applications that run and are easy to manage. So we have a solution in that space, Oracle has a solution in that space, but we're really interested to hear from you guys about what you're doing there. How are you solving that problem yourselves? So Violetta, I think we've got a poll for our attendees.
We do.
Pop that up.
Sure, let me just launch it.
If you guys could just take a moment to have a look at this this poll. We've got some questions about, so what's your approach? How are you doing hybrid container management? So we're getting some answers coming in. It's really great. You're taking the time to answer those. Okay. So these answers are coming in slowly now. We've got 12 respondees. Please take the time to answer. But what it's looking like in looking at those answers there is really, it's skewing towards people are curious. People are looking to see how they solve that problem. Some people have picked a solution already, and some folk are using kind of basic observability and monitoring tools. So let's have a look. Are we getting any more responses in there? I think we've got 63% of those responded. It's not going up anymore. Do you want to end that, Violetta, and we can have a look and see what the scores on the doors are?
Yeah, let's share the results. Right.
That's brilliant. So, I mean, it seems to, you've ended the poll. Are you going to share those results?
I have done this already. You couldn't see them?
There we go. Now I can see it now.
Yeah, all right.
So there's some interesting results there, that there's a lot of curiosity in this space. So 80% of the respondents want to know how they solve that problem. A few, 7% are using proprietary offerings, and 14% are just using tools for monitoring applications, but no one seems to have an appetite for building their own stack, because that is a lot of work to take a set of tools that allow you to solve these challenges and build that stack yourself. It's a lot on top of what the workload you already have. So let's stop sharing there. I'll move that poll to the side. And we can go on with talking about what Oracle has in this space. So we have a solution called Verrazano. So any sort of solution you want in this, and you need that solution to provide these sort of capabilities for you. Verrazano does that. We've got intelligent workload management across environments. We have the ability to have a model inside Verrazano that allows us to model and package our applications, deploy those across different places, and integrate with our DevOps tooling that we might have in-house. We've got automated and built-in observability and management. We can deal with multiple Kubernetes clusters in our environment, in our Verrazano setup, and we've got inbuilt security as well. So that's what it provides to us. But what do we get in the box? What does Verrazano have when we unpack it and install it, either on our laptop or in some sort of a demo environment? And I always say there's kind of three things that Verrazano brings to the table. And the first one is what you see in front of you there with these logos. It is a curated, ready-to-go stack of best-of-breed solutions for all of the problems that you have. So we have, perhaps some of those logos look familiar. So we have a service mesh in Istio. We have observability and management and monitoring provided with Grafana and Prometheus. We have log aggregation with OpenSearch. And these are all bundled, all certified to work together. They all install with a single installer and give you those capabilities that you need for looking after your applications. The choice is you could pick point solutions in all of these problem spaces yourself, integrate them yourself, but Verrazano gives you it ready to go. The second thing Verrazano brings to the table is the ability to run heterogeneous application types. So we have the ability in Verrazano to run more traditional Oracle applications with WebLogic and Coherence, our in-memory data grid. We can run more modern Java-based microservices. So we support Micronaut and Helidon, which are frameworks from Oracle for microservices. We also support on Verrazano Spring Boot applications. And we can also run what we could call traditional non-Java microservices, things built with Ruby or Node.js or Python. Any sort of containerized application, we can also run those on top of Verrazano. And the third thing it brings to the table is the ability to run Verrazano almost anywhere. So we obviously need Kubernetes. We are talking about containerized applications, but that Kubernetes can be on-premise, it can be in a public cloud, or what we're going to show you today is we can blend the two together to have a multi-cloud offering, a hybrid offering. So we're going to do a lot of our demos on-premise with in our Oracle Solution Center lab. We're going to use Oracle's hybrid compute stack. So we're going to build on top of Oracle's engineered systems. We're going to run our Kubernetes that comes from Oracle Linux with our cloud-native environment, and we're going to be deploying Verrazano on top of that. And we'll also add in later our managed Kubernetes service in the Oracle Cloud Infrastructure public cloud. So just to go through some of what these components in Verrazano bring to the table. So we have a service mesh, and what a service mesh allows you to do is secure network traffic between applications inside your Kubernetes cluster. So that's that east-west traffic. So when we deploy modern microservice applications, they're often very chatty. The components or microservices will call each other as the result of a client call coming in. You can have multiple internal calls. And Istio, the way it's deployed and packaged with Verrazano, allows you to automatically secure that traffic, secure it with mutual TLS, and also to visualize that traffic to work out how, from a network perspective, is your application performing. And what Istio also gives us is a single point of ingress into our applications deployed on Verrazano. So we use what's called the Istio Ingress Gateway. That applies security and TLS to the outside world to secure our north-south traffic. So that's the inbound client traffic coming into all of our applications in our Verrazano cluster. So we get Istio out of the box with Verrazano. We also have out-of-the-box monitoring and observability. So we use Grafana and Prometheus. These are installed again as part of the Verrazano stack. And many of the applications we'll deploy in Verrazano are automatically wired into this stack. So we can start to pull out metrics. They end up in the Prometheus time series database. And we have a ready-built set of dashboards inside Verrazano that allows us to keep an eye on what's happening with our applications from a performance point of view. And you can extend this, you can build your own dashboards, you can modify the ones that are shipped as well, and you can use alerts. So we can set up alerts with Alert Manager in Grafana that allow us to send alerts outbound to perhaps a Slack channel that tells us if something is going wrong with the applications deployed on Verrazano. We also have automatic log aggregation, so we're using FluentD deployed along with our applications to scrape those logs out and put those into OpenSearch. And OpenSearch allows us to search our logs, whether they're from 1 or 10 or 20 containers deployed on Verrazano. So, and most of the time, if we're following the best practices, these are automatically wired into our application. And when we start to add multiple Kubernetes clusters to our Verrazano setup, we need a tool to manage all those Kubernetes clusters at the cluster level very easily. And we ship Rancher there, which is an open source multi-cluster management tool. And you'll see Arif using that to manage both the on-premise Kubernetes clusters we have and the clusters that we're going to add from Oracle's public cloud. So it's a great tool, and again, installed as part of that Verrazano curated stack. And we also have a single sign-on solution with Keycloak. And Keycloak is used here in Verrazano both to secure access to the administrators of Verrazano, to access to the consoles, the web-based consoles that they'll use. And it's also available to the guys that deploy applications to Verrazano to enable single sign-on and federations to third-party identity management systems outside of Verrazano. So the whole, and we'll talk a little bit about some of the other stuff as part of the demo, but there's a whole suite of out-of-the-box tools that allows us to manage our applications properly. And we're going to talk a little bit more in depth very quickly before we pass over to Arif around some of the other components. So as well as the management stack, we have a set of runtimes that allow us to run those heterogeneous applications. And many of those runtimes are based on the operator pattern. So the operator pattern in Kubernetes is a way of extending the standard API and adding application-specific intelligence. So rather than just having to deal with the base resources that exist in the Kubernetes API, like pods, resource deployments, stateful sets, etc., we can add knowledge of a specific application. And that is done by adding what's called a custom resource definition. And that custom resource definition will be a set of fields and terms that are familiar to the user of that application. And we also have a custom controller, and that custom controller will sit and listen for requests to the Kubernetes API for this custom resource definition. And what it will do is intercept it, and it will break down the definition of that high-level application into the base Kubernetes resources for us. And it's a standard pattern in Kubernetes. It isn't something Oracle has invented. It's used by many other vendors, and we as Oracle have published a whole lot of operators, that some of which are bundled with Verrazano. And the first of those is the WebLogic operator. So if you're a Java EE customer running Java EE applications, you have the ability to run those and bring those to Verrazano with our WebLogic Kubernetes operator. It's part of a larger toolkit. Some items in that toolkit allow us to introspect on-premise WebLogic installations and pull everything we need out of that to containerize it very quickly and effectively on your behalf, and then move that to Verrazano. But the operator sits inside the Verrazano install, and we were able to define a custom resource in terms that a WebLogic admin would understand. So things like managed servers, admin servers, clusters for WebLogic clusters, and the services that make those speak to each other. And it manages the lifecycle, so we can deploy it. We'll end up with a running WebLogic application, and we can use the operator to manage its lifecycle. So we can scale it, we can patch it, we can stop and start it. So the operator provides an awful lot more beyond the first installation and running of a WebLogic operator, WebLogic deployment. So that's the WebLogic operator. We also have bundled with Verrazano a coherence operator that allows us to run in the same manner in-memory data grid projects and applications, so we can deploy with a custom resource definition understood by the coherence operator, an in-memory data grid that can run multiple pods and multiple coherence clusters that do their magic and cluster together and share primary and secondary key value pairs of data across a grid. And so again, they're out of the box, they're built as part of the Verrazano installation. And we also, in Verrazano, have adopted what's called the open application model. And this is the packaging standard for our applications that allows us to separate the guys that build the components, the infrastructure administrator, and the guys that do the deployment. So open application model is a standard that came out of Alibaba and Microsoft. And as we said, it's a packaging standard, a little bit analogous to the Java EE packaging standard, but allows you to define a microservice application as a set of components, a set of traits that we add to those components. And those traits can be things, as you can see in the diagram here, like auto-scaling, identity, perhaps traffic management with ingress. In our case, we can do logging, etc. And those traits depend on the specific open application runtime. And Verrazano has an open application runtime. And in effect, what this allows you to do is separate these concerns. So the tasks of the administrator, the guy that produces your Verrazano environment, that looks after it for you, he sets up that OAM capable Verrazano environment. We have development teams that produce individual components that are going to make up microservice applications. So they build those, they containerize them, and they ship them as an OAM component with perhaps a component manifest that has the container and the spec and what type of workload it is. And they can be from a variety of different workload types. And then we have that application deployer whose task is to take those components, compose them into a larger OAM application, add the traits that we talked about. So the most important one being an ingress trait that defines how the outside world can make requests to our application, and deploys them to the Verrazano environment provided by the administrator. And there's a kind of different set of constructs we use. So if we're running vanilla Kubernetes, we're talking about stateful sets, deployments, persistent volumes. Our network access might be via Kubernetes load balancer, or we might choose to install and maintain our own ingress controller. The logging, we'll have to work out how to do that in the plain Kubernetes world. And our metrics, how are we going to do metrics? We need to make sure that the applications are built to expose the metrics, and we need a metrics platform in our Kubernetes cluster. With Verrazano, our applications are deployed as the OAM components we've talked about, and we can have various different workload types, the WebLogic and coherence ones we've mentioned. We can have a Helidon microservice workload type. We can have a vanilla containerized workload type that we might use to deploy Spring Boot applications. And then we will add network access behavior with what's called an ingress trait. And this defines what host name we want to use, what path we want to access in the application, and how we expose it to the outside world. We could add a logging trait if we've got custom logging. If we follow container best practices, the logging is automatic and out of the box, it's auto-wired. And likewise for metrics, if we have specific metrics we want to scrape, we can add a metrics trait. If we follow containerization best practices, those metrics are automatically scraped, added to Prometheus, and exposed in Grafana for us. So it does an awful lot for us. The OAM runtime inside Verrazano does an awful lot for us. And this is essentially how it works. Those teams developing and delivering those components, those will be assembled into a component.yaml file. We will add them in an application config file. So it's all YAML, it's cloud native, there's no escape from YAML, but those traits will be added at that point, perhaps ingress, perhaps a scaling trait to allow us to scale our applications. And we will deploy that to the Verrazano cluster we have running. And we use the standard Kubernetes API, kubectl or some CICD tool that will be intercepted in the example we see in front of us by the Verrazano operators, passed off to individual operators for different workload types. And you can see those components there being put into service. The traffic between them is secured with Istio, with mutual TLS, and they're auto-wired into our observability and management platform you see in the blue on the diagram in front of you. And because we've added an ingress trait, we have ingress available to the outside world, to our clients, our consumers of our application. And this is what Arif's going to show us just now. So we've got a ready-made Verrazano deployment in our OSC lab. It's running on an Oracle engineered system with our cloud native environment Kubernetes distribution. We've got a sample application called Aussie Tripper. We're going to use kubectl, so a standard tool, but you could wire this up to a CICD tool that understands Kubernetes. we've got an OAM application file, which we will deploy. That will be intercepted by the Verrazano operator. It will detect the various components in there. And the example we've got for you today is a WebLogic one. We can have lots of different workload types that will cause a container image to be pulled from our container registry, to be put into service, and the operator will turn that into a set of pods and a running OAM application. So Arif, and then we're going to show how that application is wired into the value-add tools. So we've got Rancher, we're going to show you Grafana, OpenSearch, and the network traffic with Kiali. So, and then we're going to scale that application. So we'll show the lifecycle management, we'll fire that over, and scale that WebLogic application running in Verrazano. So I'm going to hand over to you, Arif, for the demo.
Thank you, Angus. So good morning, everyone, and thank you for joining us today. So my name's Arif Saddiq. I work alongside Angus and Mark in Oracle Solution Center. And hopefully in this demo, I will aim to show you how we can manage a Kubernetes cluster using Verrazano and how we can manage multiple clusters. So let me just share my screen first. So hopefully everyone can see my screen. I'm just going to stop my video while I run through the demo. Okay, so in preparation for this demo, I've already created a Kubernetes cluster and installed Verrazano onto it. So this will be known as the admin cluster. So if I run kubectl nodes, you can see this is my simple cluster. It's got one master node and two worker nodes. Now, the Verrazano installation is fairly straightforward. First, I installed the Verrazano platform operator to manage the life cycle of this Verrazano installation. And then we can apply the Verrazano installation profile, which installs all the Verrazano components onto the cluster. And this command here will show you all the pods that have been deployed as part of this. So, paste that in. You can see here are all the pods that have been deployed as part of the Verrazano installation. So with that in place, we can now actually go ahead and access our Verrazano console. So if I make my way over here. So this here is our Verrazano console. And this user interface allows us to interact with our applications and configurations. So from this console, we can find information about our Verrazano environment, like the status and versions, the application and project resources we've deployed. As well as that, we can get access to the various consoles like Rancher, Keycloak, and the consoles for our telemetry data. Now, the console acts as a single pane of glass to see a sort of high-level overview of our Verrazano environment.
Arif, could you just increase some font size, please? That's been requested. Thank you.
Okay, on the terminal.
And the browser, just one more on the browser. That's great, thanks.
Okay, so like I was saying, that this console acts as a sort of single pane of glass to see a high-level overview of our environment. Now, to see the actual workloads that we're deploying to the cluster, we could interrogate the cluster using the kubectl command line. However, one of the tools that is installed with Verrazano is Rancher. Now, Rancher is this open source container management platform, and it provides a handy graphical interface for monitoring and managing our clusters. And is extremely useful for when managing multiple clusters. So if I click on this link here, it'll take me to the Rancher dashboard. Let's log in. Okay, so here we can see our one cluster, which is registered in Rancher, and this is our admin cluster. So if I click into that, and here we can now start to get some more information about this cluster. So if I looked at nodes, for example, this shows us the makeup of our cluster, and we can get some stats, etc., around the nodes. So you can see we have our one master node here and our two worker nodes. And then under workload, we will see any what applications or workloads that are deployed should appear here. So with that said, I'm sort of now ready to deploy our first application. So Verrazano provides an implementation for WebLogic workloads, as Angus has mentioned. So now I'm going to demonstrate a deployment of a WebLogic application whereby we shall lift and shift on-premise WebLogic application, containerize it, and deploy it to Kubernetes. Now, in the interest of time, the lift part has already been done using the WebLogic image tool, which basically introspects our on-premise WebLogic domain, and then it will generate these OAM deployment artifacts and manifest files that we can then use to deploy our Kubernetes environment application here. So the first thing I need to do, so I just made that, let's just clear that. So here are all the files that were generated from that image tool. And the first thing I want to do is create a project. Now, a Verrazano project, it provides a way to group application namespaces and grant access and to users groups or even service accounts for anything deployed in that project. So if I show you this Verrazano project. And basically all I'm doing here is I'm creating this namespace called Aussie Tripper. Okay. What I want to do. Okay, so if I go back to the Verrazano console, we look at the projects, we should hopefully see here our project called Aussie Tripper. Yeah. So right now we've just created the namespace and the project, nothing's been deployed yet. What I can do now is apply the application manifest, which is this one here, and this will deploy our WebLogic environment. So if I just refresh this, so hopefully in here we should see our OAM application. Yeah, so you can see Aussie Tripper has been deployed to the local cluster, which is what's the Verrazano is running on. And then if I go into Rancher, we can actually see the pods that are being deployed as part of this deployment. So you can see deployment. So we can see here, it's already started a job. So this is an introspect job. Basically an introspect job, first thing I'll do is I'll just verify that all the components and everything that we've defined in this manifest file are available. And if it passes the check, then I'll go ahead and deploy the actual pods that it needs to. So while that's deployment, what we can quickly do is look at the manifest file itself to see what we're actually deploying here. So this is our manifest file, and in this part here, this first part here, we can see the traits that Angus mentioned. So we have a trait for a metrics trait, so it's basically telling Prometheus how to pull the metrics for our WebLogic application. And then we have this trait that opens up the ingress endpoint so that we can access our application, which will be deployed in WebLogic. So we have an application called Aussie Tripper, which will eventually be deployed into our WebLogic environment, and we'll be able to access it using the endpoint and /Aussie Tripper. And we've also opened up an endpoint for the actual WebLogic console itself. So this is sort of specific to Verrazano, the traits that are involved that we want to configure. Down here is more to do with the actual WebLogic environment that we're deploying. So you can see we're specifying the domain home for our WebLogic. This here is the container image that will be pulled that's actually pulling here and creating these pods. And that was generated from the WebLogic image tool, pushed up to our registry, and then we're just basically pulling it down and allowing Kubernetes to install that for us. Okay, so I can see here that our pods have been deployed successfully. So we have one admin server and one managed server. So anyone familiar with WebLogic, you have an admin server, and then we have just one managed server at the moment. So in theory, I should be able to now get the endpoint for this application. And this is generated by Verrazano for us. So if I run this, and you can see here it's generated this endpoint address. So copy that. Now, if I put in /console, this should hopefully get us to the WebLogic console that's using the operator that's bundled in with Verrazano. So you can see it's first time I'm accessing it. So yeah, we have a WebLogic console. So and also we've deployed this Aussie Tripper app. So you could see in the manifest file I showed you that the endpoint of that was /Aussie Tripper. So if I now put in Aussie Tripper, yeah, and there you go. It's just a simple app that sort of tracks our holiday in Australia, and we can click on that. You can see which managed server in WebLogic is actually answering our requests. So that's our application deployed. So what I want to show you now is the sort of value add tooling that comes with Verrazano. So we've got our application, now we want to get some information around it. So we'll go back to Verrazano console itself. So the first thing we can look at is, I'll show you the sort of Prometheus and Grafana. Now Prometheus is a monitoring solution for storing sort of time series data like metrics, and Grafana, it allows us to visualize the data stored in Prometheus. So again, you've seen in the manifest file, I'm using Prometheus to scrape this information from our application, and then we'll use Grafana to sort of visualize this data that's been pulled. Now out of the box, there's all these predefined dashboards that come with it. So if it was a coherence app, you could click on one of the coherence dashboards. Since we're using WebLogic, I'll click on the WebLogic dashboard, and here we can see our one server running, our one managed server, and then now we can start to get sort of monitoring stats around our managed server. Yeah, so there's a lot of information there. You can see all the sessions, etc., the load, the running time, number of sockets open. So there's a whole lot of information that we can get here. So that's Grafana. And we also have an OpenSearch dashboard as well. So if I click on this, and the OpenSearch console is a log explorer that collects all the logs from the pods that are deployed as part of the workload. And it makes it easy for you to perform interactive log analytics and real-time application monitoring. So I think I clicked on the wrong one there. Yeah, so I'll now go into Discovery and we'll select the namespace Aussie Tripper application. And here we can see all the logs that are available as part of this deployment. So for every pod deployed in the Aussie Tripper namespace, Prometheus is scraping that log information into a central area, and we can now filter out the data, and we can see it all from a sort of this one single console. And as an example, we can use the search field. So when in WebLogic, when you start up an instance, for example, it always generates a specific code. So this is the code here. And what I can do is I can now search for this code. and it'll show me anytime a WebLogic instance was started and running, and then we can filter out by the container image. So yeah, so you can see here there's the logs that is pulled for the admin server and the so drill it down a bit more. Yeah. So we can see the two logs. We have one log for our admin server and one log for our managed server. Yeah. So that's sort of the log aggregation. So what I'll do now is I'll show you this. Next one is Kiali. And Kiali is a management console for the STO service mesh. And it helps us understand the structure and health of our service mesh by monitoring the traffic flow. So if I can find that. I'm looking for STO. Oh, there it is. And we'll just enable a few things here. So we'll enable traffic animation and we'll show the traffic rate. Now, at the moment, it's showing nothing because we're not actually using our application at the moment. And so if I went back to Aussie Tripper and started clicking on the map here, this is generating a bit of traffic, and we'll see something appear in the Kiali console. To just simulate sort of an excessive workload to this application, what I'm going to do is I'm just going to run this curl command, which I can get it. Yeah, so all I'm doing here is I'm running this little script that will constantly be hitting Brisbane. So it's like somebody is constantly clicking that. But what I will do is I'll generate traffic to our application, and hopefully we should see this appear in our Kiali console. So you can see that there's traffic is flowing, being answered by our managed server in WebLogic. Eventually you'll see it's going to build up, and you see that the load's getting very excessive here. And visually we can see that our one managed server here is being overloaded with traffic. So what I'll do is I'll show you scaling up our WebLogic instances. So we'll go back to the manifest that I deployed originally. So in here we have this field called replicas, and replicas just tells you the number of managed servers we want started in this cluster. That we can potentially have up to 5. That's the way I've configured it, but what I'm going to do is change that to 2. And then we'll reapply this manifest file. Okay, so what should happen here now is that it should sense that I need another managed server. So you can see it's already started to deploy a second managed server. So we'll give that a few moments to start up. Yeah, it's almost starting. And then once this managed server has started up, we should hopefully in the Kiali console see another managed server appear, and then the load being shared across this. And I mean, I could have enabled 3, 4, 5, 6, as many as you like, based on the sort of traffic load going to our endpoint. Let me just see if that's, yeah. So the managed server is deployed. So hopefully we just leave this for a few moments. We should see a second managed server appear. And then we know that our traffic is being shared across these 2 managed servers. And likewise in the Grafana as well, find the Grafana. That should hopefully show us 2 managed servers in there as well. Yeah, so you can see it's picked up that I now have 2 managed servers, so we can now start monitoring these 2 managed servers. If we go back to Kali console, we can see here that is also now sharing the loads across these 2 managed servers.
That's
so
awesome, Arif.
With that, I'm going to run back to Angus.
Thank you very much, Arif. Let me just show my slides. So we're going to get a shift on and change our focus now. So we've shown how Verrazano works. We've deployed a sample application. It was a WebLogic one. We could have picked any of the different workload types that Verrazano supports, but we went with that one. And what we're going to do now is talk to you about how we can expand our Verrazano setup. Everything Arif has done has been on a single Kubernetes cluster. And there are lots of scenarios where you, as a customer, might need to manage more than one Kubernetes cluster. You will want, obviously, the same Verrazano capabilities across all of those, and you might want to extend it to the public cloud. And we're talking about the model that you see on the screen in front of you. What we recommend for more ambitious Verrazano deployments is we have an admin Kubernetes cluster running Verrazano with all of the monitoring and management tooling that Arif has just shown you. And we install what we call managed clusters, one or more managed clusters, whose task is to have the Verrazano runtimes and to be tasked with running the actual applications. And we can auto-wire these together. So all of that capability that Arif has shown you happens with shipping logs back from these remote containers, metrics, etc., and deployments of applications in the opposite direction from the admin cluster to the managed clusters. We have this concept of profiles in Verrazanos. Arif has shown you a Verrazano cluster with the prod profile, which is full fat, everything installed. We're now going to install and register managed Verrazano clusters that just have the runtime, and we're going to register those with that admin cluster. And just out of interest, there's also a dev profile. You can run this on your laptop, so you can start to explore Verrazano on your own laptop. But we're going to use the prod and the managed cluster profiles now. So we're going to take that admin cluster that we're running right now. It's running our application. It's running the full Verrazano stack. We've already got another Verrazano cluster running in Oracle's public cloud. So we're going to split our Verrazano environment across on-prem and the public cloud. We're going to use kubectl, and we're going to run this register cluster process. So that will let the admin cluster know that there is a managed cluster it needs to look after. And it will set up the links between them for log aggregation and metrics, and also for the admin cluster to deploy applications to the managed cluster. And then what we'll do is we'll change the placement request in our OAM application file, and we will actually cause that Aussie Tripper application to be undeployed from the admin cluster and redeployed to the public cloud for us. Perhaps we want to expose that to the wider world so they can all enjoy a trip around Australia. So what I'm going to do now is hand over really quickly to Arif so he can show us the registration process and how we bring in a Verrazano cluster in the public cloud. Okay, it looks good, Arif. I can see your screen, but I can't hear you.
You're on mute, Arif.
Oh, okay. Sorry. Can you hear me now? Yeah. So up until now, I've only showed an application being deployed on the admin cluster. Now, whilst this is okay for my demo, best practice would be to dedicate this admin cluster to just the Verrazano installation itself, but then to have another cluster or many clusters which we can deploy our containerized workloads to. Now, one of the key benefits and advantages of Verrazano is the ability to manage multiple clusters. So here we could add another OCNE cluster or even an OKE cluster to our environment, then use the admin cluster as a central management point for deploying and monitoring applications to our managed clusters. Now, so like the admin cluster we've currently been working with, I've created another on-premise cluster called Managed One, and I've also created an OKE cluster on our hybrid tenancy in Oracle's cloud. So I'll show you the Managed One cluster first. So you can see here, this is another cluster made up the same way, one master node and two worker nodes. and also have this one, which is our cluster, which is actually running in Oracle's cloud. And I can show you that here. So this is me in the OCI console. And if we go to Kubernetes containers, you can see here, this is the cluster here that I'm showing you. And if we go inside that, we can see that it's got one node pool, and that one node pool has 3 worker nodes, and these are the 3 worker nodes that we can see here. Okay, so if I go back to Verrazano, when we look under clusters, right now we can see that there's no additional clusters being deployed. We just have the one admin cluster. So I'm going to now register these 2 clusters. So in each cluster, I've already installed the Verrazano operator and the installation profile. However, the installation profile, as Angus mentioned, we deployed on the managed cluster is slightly different in that I will only install a subset of the components required for it to act as a managed cluster. So let me go ahead and just register these. So first thing I'll do is I'll show you. So we simply deploy this Verrazano managed cluster object on the admin cluster. This will then generate a YAML file that we can then apply to the managed cluster to complete the registration process. So if I just quickly run through that. So if I apply this, okay, so it's created the secret, and then I just run a little script just to get that registration profile. And what is created is this registration.yaml, and then we'll apply this to the managed one cluster. So I run this. So I'm just applying register.yaml to managed one cluster. Okay, and likewise, I'm going to do the same with our OKE cluster. We'll go in there. And get register script again. And this downloads this register.yaml file, and then I'll just apply this to this time to the OKE cluster, so you can see managed OCI. And hopefully, if I refresh this, under clusters, we should see 2 additional clusters appear. Yeah, so we can see managed one and managed OCI. And then if we go into Rancher, look under clusters, we can see that it's still it's already registered managed one, and any moment now we'll have the OKE cluster in an active state. Okay, so there we go. So I can now go in and look at the makeup of any of these. Now, so as I said, typically in a production environment, the admin cluster would be reserved for the Verrazano install, and these managed clusters would be used as a deployment target for our apps. So we can now redeploy the application to the managed clusters. Now, without Verrazano, if I wanted to deploy an app, for example, to manage one, I would need to point my kube config file to that cluster and then apply the manifest files for that deployment. However, since this is a Verrazano multi-cluster setup where everything is managed centrally from the admin cluster, including the monitoring and the metrics for all the clusters, we can apply the manifest directly to the admin cluster. But what we can do is inside these files, we can define the multi-cluster resource that dictates which cluster the admin cluster will deploy the app to. So what I mean by this, so if I go back to my application files, so these were the files I initially deployed on the local cluster. And look inside here. So here you can see there's a field called placement. And so what I can do is now I can add in the names of these two additional clusters. If I do that. So what happens when I apply this project, I will now create the namespaces in all three clusters. So it's already been deployed to local. If I, for example, was to remove this and apply this, it would actually remove that deployment from the local cluster and just deploy it on these two. But I'm just going to leave it in here. So we're now going to deploy it to all three clusters. Apply that. So that's created the namespaces in all our clusters. I'll do the same in our application. This has a placement field in it as well. Okay, so now apply that. And when I'm applying this, so my kube config right now is pointing to the admin cluster. Even though I'm going to be deploying these applications onto managed one and managed OCI, I'm still deploying these manifest files to the admin cluster. The admin cluster in Verrazano will then deploy them to whichever cluster I defined in that placement field. So if I go back to here, you can do. If I look under OEM apps, we can see now that this application not only is on the local cluster, it's on managed one and managed OCI, and it's pending state because it's deploying at the moment. And we should hopefully, if we go into one of the clusters, so if we look at managed, let's look at managed. So we'll look at the OKI cluster. We'll look at pods, and I'll just filter out the namespace of the triple. So you can see it's already started to deploy our WebLogic environment. So it's doing the introspect job here. Likewise, in managed one should be the same. We'll just filter out positripper. So it's just deploying to there. So we can see that our application is now being deployed to all three clusters now. And now what it means is that we can now go, if we go back to Verrazano console, if we were to look at one of the dashboards again, so not only will it be collecting the data from the admin cluster, but it will now be collecting the data from these two additional managed clusters. And the great bit is that it's pulling it all into one place. So it's one area where we can see the monitoring for our applications that have been deployed across 3 different clusters. So if I was to look at the WebLogic dashboard again, and then we can now filter out, so you can see the local, our WebLogic instance has been running for a while. If I was to go to managed one, so it's still not picked up on it yet. So we just need to wait for that to be deployed. Yeah, it's still installing the managed servers, but as soon as that is installed and it starts generating some metrics data, we will see that in the Grafana dashboard. Yeah, so that's done there. Just have a look at the managed OCI one. Yeah, and it's almost finished in our OKE cluster. So hopefully, just need to wait a little bit for it to appear. So this is still in local. Look at managed one. Yeah, so there we can see it's now monitoring these servers in our managed one cluster, and you'll notice that it's only just started, so we're only just picking up on the data compared to the local one, which has been running for the last 5-10 minutes. Yeah, and so that not only the monitoring, we can also do the same with our OpenSearch dashboard. So if I was to go into here, and we look at the same, it's the same Aussie Tripper namespace, and so now we can actually filter out by the cluster that has been deployed on. So if I do cluster name, so you can see it's already picked up. There's 2 clusters here. I'll pick up on the 3rd one eventually, and then we could just, filter out and just see the logs for managed anything deployed in the OKE cluster or on anything deployed in managed one. So you can see, I mean, without this sort of setup, if you had many clusters and you wanted to debug or look at the logs or collect the logs, you would be logging into every single cluster, into each pod, grabbing these logs. Here it's all at your fingertips, and you can filter out an individual log right down to the cluster that has been deployed on. So, but that's essentially all I had to show, Angus. So I'll hand back to you.
That's
but yeah, so you can see managed one has picked up on that now as well.
Awesome. Thank you very much, Arif. So it's a really great live demo as ever. I don't know how you get away with it, Arif, making these live demos work so smoothly every time, but it's been really interesting. And I think, it's easy to see where this multi-cluster management would be useful. So we've spanned our Verrazano installation across both on-prem and Oracle's public cloud. It could be multiple regions in Oracle's public cloud. Perhaps you had an internet-facing application that you want to deliver to lots of different regions. We maybe want to choose to run our dev and test environments in the public cloud because it's cheaper, and our prod on-prem. Verrazano can help you with that. We might want to have different applications at different locations. Super demo, and what we've got here is, if you're interested in Verrazano, there's a whole load of additional resources for you to explore Verrazano, find out a little bit more about it. And as I've mentioned, it's entirely possible to run Verrazano on your laptop. You can use that dev profile, run it on your laptop. On the Verrazano documentation page, there's lots of starter applications you can run and deploy and start to explore it. So we're a little bit over, so I apologize for that, but thank you for your attention and staying with us. It's been great to have your time. If you've got any questions, we'll be here to answer them for a few more minutes. And this video and the slide deck will be shared with you guys a little bit later on.